Hello everyone, my name is Eric Onyami. I am presenting our work titled CureMed, Curriculum-Informed Reinforcement Learning for Multilingual Medical Reasoning. We are answering a simple question. We want to ensure that AI models 1. Respond correctly and accurately in the language of the question and also generate responses in the language of the question and not be limited to certain languages only. I personally believe that medical AI is not truly reliable until it can reason and respond safely in the language of the patient. Let's go through some background. Modern AI models are highly fluent in English and other high-resource languages, but if you prompt them in languages like Swahili, Yoruba, Bengali, you can see that the models fail to respond correctly as they are supposed to. As we train models and we release them globally to the world, multilingual LLM is expanding, but coverage remains uneven across languages. And to serve every community equally in the medical domain, we must make sure that there is an equal distribution. Medical LLMs benchmark focus mostly on close-ended question answering, leaving open-ended out, and also low-resource languages remains underexplored. This is the problem that we aim to solve, and this is our motivation. LLM reasoning sounds fluent but is often clinically wrong and drifts out of the patient's language. Let us consider these two scenarios. We have a query in English. So the question is in English, but when the model begins to respond to the query from the user, at some point in its reasoning, it drifts to a language that the user is not aware of before arriving at the final answer. There is what we call the language drifting here. And because it sounds plausible, it's ended on a very wrong answer. And this will reduce trust in the models for the user. Also, the question is in Spanish, but as the model begins to respond to the query, mid-reasoning, the model switches to English. Assuming the user do not understand or cannot read English, the user is not going to benefit from the question that it is asking the model, and the final answer, which mostly faces the user, is also mixed with English and Spanish. It is clinically wrong and there's language drifting as well. This is a challenge, this is a problem that our research aims to solve, and this is our main motivation. Existing benchmark focuses on close-ended questions. There are a lot of benchmark data sets on mathematical and logical reasoning. There is a strong focus on English and high-resource languages with limited coverage of low-resource languages. Multilingual medical reasoning is a field that remains underexplored. The two main challenges with multilingual medical reasoning is one, reduced logical accuracy, where models respond correctly in some languages, but if you prompt them in other languages like Yoruba and Swahili, their accuracy reduces. There's language drift, where models mix the language that they use to respond or they are being prompted in with other languages. This is why we introduced our framework called CureMed. CureMed A is in 3 stages. That is, at stage 0, we created a multilingual medical reasoning dataset, from a clinically validated source. Then at stage 1, we use this dataset to train our model through supervised fine-tuning to teach reasoning stability and answer format. And then at stage 2, we introduce the curriculum guided GRPO framework, where we train in stages to ensure that we give rewards for model answering rightly and following language consistency and answer format as well. Our details of our benchmark consists of 13 different languages, from French to Bengali, French having about 13.5 and Bengali having 2.9%. And our dataset is unique in its own way. It is an open-ended dataset as compared to others. It is reasoning supervision, that is step-by-step reasoning approach, and we also covered low-resource languages. Our method, the first method that we use on our dataset is supervised fine-tuning on our code switch medical reasoning traces. When we talk about code switching, we are trying to ensure that the model uses the language that it is most familiar with, which is English. Okay, so that as it is answering, when it is struggling to answer in the target language that it is being prompted in, it should switch to that to the language that it is most familiar with. This is just a training framework, but the main answer that faces the user is always in the language that the model is being prompted in. So we taught the model step-by-step reasoning and how to also give its final answer. After the supervised fine-tuning stage, we moved on to the reward, that's the reinforcement learning stage, where we considered correctness, language consistency, and correct answer format. Our training for the curriculum reinforcement learning is in 3 stages. We first train on high resource languages where models are able to easily answer questions in these languages. Then we move to mid resource languages and then low resource languages. That is, we moved in accordance to difficulty in the linguistic direction. Okay, so the low resource languages are very difficult for the models, so we use that one last. Our key contribution include CureMed-Bench, where we introduce the 15,000 plus open-ended medical reasoning dataset, and also CureMed, the training framework that we proposed that worked accurately. Our result shows that CureMed outperform baselines on both metrics. If you check our best performing model, which is the 32 billion parameter model, it outperforms all other models. It outperforms 72 billion and then 70 billion models as well. And then even our 7 billion model outperforms most of the existing benchmarks. This is the trade-off that we've seen here, that our model continuously improves to the top right, okay, where we see that in terms of language consistency and logical accuracy, our model, which is CureMed, which is represented by star, beats all other benchmarks. CureMed also scales very well, okay, it scales very well as the model parameter increases. CureMed scales very well as compared to the baseline. The CureMed is in red and it scales well as compared to the baseline on both logical accuracy and then language consistency. We also checked the performance on other datasets, that's the MEDQA, MEDSQA, and we see that our benchmark, all other benchmark models, okay, as compared to CureMed works better than they all. Also, in out-of-domain generalization, CureMed beats baseline models as well. In conclusion, we propose CureMed, that is a training framework which helps to improve logical accuracy and then language consistency across 13 languages. And we also introduce a benchmark data set across 13 different languages. Thank you very much. I am in UVA School of Data Science. I work with the ICAM lab, and you can scan this QR code to read more about our work. Thank you.